Okay, so now for our fourth step, the next thing we're going to have to do is we need to somehow turn one of those OHs into a good leaving group. So the H that we just took off right here with this second equivalent of alcohol is going to come back. So let me do that. So we've got this, right? And then that H that we removed just now. This is positively charged. Okay, it's still floating around in solution. And so one of these OHs, I guess we'll use this one, is going to grab that hydrogen off. Okay, so yeah, so it should be like this. All right, don't forget your next arrow. Let me write out that step for you. So OH grabs the H that was just deprotonated. Okay. So now what we have is this. We've got our OH up here that was untouched. We have our OR. And we have this water, which is positively charged, of course, because 3 bonds to oxygen. And it's also a very good, what? Nice. I know you're all saying leaving group. Very good. So that's exactly what we need. So the next step, of course, is what? These electrons are going to come down and form a double bond that we need for our ester, and they're going to subsequently kick off our great leaving group that we have right now. So step 5, OH lone pair electrons donate to form a double bond and kick off our water leaving group, which is a great leaving group, of course. That's why we needed to make it. Oops. Okay. Cool. So now what we have is this. That methyl group that was not touched at all. We got our new double bond. Okay, we still have that H, so it's going to be positively charged up here. And now that this water leaving group is gone, we have our OR. So we have our, this is our protonated ester at this point. So, oops. So the last thing we need to do, step 6, is, as you can guess, right, so we can get our final ester product, is to deprotonate. And what can do the deprotonation? So as many of you would have realized, you could probably use water to deprotonate, right? But it doesn't actually make a difference. You could also use the HSO4 minus counter ion, because in the end, I'll show you in a minute, it's going to be the same outcome. So here we can grab that H off. Okay, so we're left with our ester product. That's what we wanted, right? From esterification, we made an ester. And you now have, so you have H3O plus, right? And you've also got the HSO4 minus in solution, right? But these things will combine together. They'll have a proton transfer between them, right? And you'll get water and H2SO4 back. And this is your catalyst that you regenerate. So everything works out in the end, okay? So that's Fischer esterification. You really should be very familiar with how this works. Now, of course, like I said before, up here, this reaction is reversible. So the reverse reaction is called Ester Hydrolysis. And this makes sense, right? Because hydrolysis is the breaking of some bond, right? With the addition of water, and that makes sense because we know that we have to add water to make it go this way. So to get rid of the ester, we have to add water to get to our carboxylic acid product. And it's of the ester, right? So the ester we just made. So that's why it makes sense. So for that though, you need one extra reagent. So you'll have your ester, of course, that we just made. And then you'll have to add 3 things. So you have your strong acid, which in this case I'm using HCl. You'll need water, okay? And you'll need it to be in excess, as we set up there, of course, to push the equilibrium to the left, right? And then you need THF, and this is for solubility. Okay? And by doing so, you will get your, I guess you could put an R right there too. You can get your carboxylic acid product. Okay? So the mechanism for this is very similar. It's literally the same thing but backwards. So I recommend that you try this on your own, okay? And another good way to practice would be to make your own practice problems. So like literally draw yourself an alcohol with an arbitrary R group, and same for the carboxylic acid, and see if you can get to the ester. And if you can do this and you can reason your way through it in all these steps, this should be, you know, a mechanism that you can do in your sleep. And it's really important for 8C, and it will show up again. So yeah, it's important, and I'm pretty sure it'll be on your final. So good luck with that, and click ahead to the next video.